Okay, so we have another AMC 10 problem. So this was number 15. It's just counting a question for a divisor. So we are given a number, which is 12 factorial, and we want to find a divisor that will be a perfect square, and then that's the probability that we are looking for. So the first things first, let's write the prime factorization of 12 factorial, because we just need to know the total number of divisors as well as the perfect square divisors. So 12 is like 2 is 3, 4 I can write 2 square, and 5 is just 5, 6 is 2 times 3, and I have 7. I have 8 is 2 cubed, 9 is 3 square, 10 is 2, 5, and then 11, and then 12 is 2 square, and 3. So if you just count the number of 2's, so we have 1, 3, 4, 7, 8, 10, right? So we have like 10 2's, so which is 2 to the 10th power. And the number of 3's, so we have 1, 2, 4, 5. So we have 5 3's. There is another way by using the floor notation if you kind of like doing that way. So that should be fine as well. But since this is like a smaller number, so I just write it this way. So if this is like 120 factorial, I couldn't really do this way. In that case, I would just do like, let's say 12 and divide by 2, and then I take the floor of this, right? And then plus 12 divided by 2 square. So if you remember this, basically we are trying to see how many multiple of 2's, how many multiple of 4's, because some of the multiple of 2's are also multiple of 4's. So if you have multiple of 4's that has 2 2's and stuff like that, and there is like some like numbers that is multiple 2, but that has 3 2's, which is like multiple 8's. So we just continue in this until we really get the largest power of each prime numbers that is smaller than a given number. In this case, like 12 is like we can get at most 2 cubed. So when you take the floor of this, that's just 6. There's 6 multiple of 2's. That means each one of these has at least 1 2. And then there is like 12 over 4, which is 3. So there is like 3 number that is multiple of 4. So 4, 8, and 12, which means each one of these has at least 2 2's. So we count one of these when we count the multiple of 2's, but we have another one. That's why we just add 3 more. And then for the number that is multiple of 8 has 3 2's, we count maybe one of these, like 2 of these before. You just have one more when you floor this one, which is add up to 10. So this is what we could do this way. If we have like a bit larger number, but in this case, like I kind of just go with this one without really doing this second one. But if this number like a huge number, then I would probably go with this. So now we have like 3's, and then we have 2 5's, and then we have 7 and 11. That's it. So the probability of it getting perfect square, right? So we are gonna just find the denominator is just the number of divisors. So if you remember, the counting number of divisors was we are adding 1 to each exponent and multiplying. If you kind of don't remember why, I'm gonna attach a video to explain why that's the case, so you can take a look at that. So you can just say basically any power of 2's, including 0th power, all the way to the 10th power, would be any divisor, which means there is like 11 option for 2's. So that's 10 plus 1. And then for the 3's, we have 5 plus 1, which is 6 option, because we have like 0th power of 3, first power, second, all the way to the 5th. So 6 option, and for 5, we have 3 option, and then 7, 2, and 11 is 2. This is the number of divisors. So we just need to know the numbers that is a perfect square. So to get the perfect square, so the power of prime has to be even numbers. So only numbers that we can actually work with in this case, 2, 3, and 5, not 7 and 11, because their power is not even at all. And so we should have some powers that's 2 to the A, 3 to the B, and 5 to the C, right? And then A could be 0 all the way to the 10, but we cannot choose even like odd powers. We just choose even ones. So 2, 4, 6, 8, and 10. And then for B, we can choose like 0, 2, or 4. That's the largest 5. We cannot go with 6. So the C could be 0 or 2, which means every choice that we have for A we have 3 choices to choose for B and 2 choices for C. So we have 1, 2, 3, 4, 5, 6. So 6 option for A, 3 option for B, and 2 option for C. So I can cancel this by this, this by this, this by this. So you will get just 1 over 22. But we are going to find a fraction. So m plus n is just 23. So that's the choice C. So this is a straightforward counting divisor problem. So if you couldn't really get this problem on your own, so it's better to do a little bit practice on this, because this is a number 15 from the recent year, so which shouldn't be too complicated looking. So when you actually know the basics of the counting divisors, I'll see you in the next video.